In this video, we are going to cover properties of liquids. Please read the OER textbook chapter section 10.2. In the previous video, we're looking at what is the intermolecular force and the type of intermolecular forces that determine the state of matter. In this video, we are going to focus our attention to the property of liquids, various property of liquid. Let's start with the first one, viscosity. Viscosity is a measure of its resistance to flow. Okay, so for example, if you have water versus honey, you will see that honey would have more resistance to flow than water. Therefore, in this case, honey would have higher viscosity, or honey is more viscous. So pretty much it's depending on two factors. The first one is going to be the strength of the IMF. Okay, so the substance that have stronger IMF, the molecules within that compound would hold with each other strongly. Therefore, it's going to cause the viscosity to be more viscous. Okay, so, and the second one is the entanglement and also the size of the molecules. If the molecule are in a large size and also they are entangled more, they are going to be most likely become more viscous. Okay, so for example, honey, for example, in this case, in comparison to water. And the last factor is going to be the temperature. Temperature also have an effect on the viscosity of the substance as well. For example, if you observe honey, right, at a higher temperature, honey would flow more would flow better than at a lower temperature, right? Honey will become more viscous at a lower temperature. Okay, so here are the table of common substance of the viscosity at 25 degrees Celsius. Again, the reason why we have to specify the temperature, because temperature also have an effect on the viscosity as well. So in this case, you probably notice that the one that has a larger size of the molecule would have a higher value of viscosity, which indicated it's going to be more viscous. For example, in this case, honey, right? Just for now, just note that mercury is, even though it's only like have the smallest formula, the reason why it's have higher viscosity is because of the metallic bonding within within atoms of mercury within the compound. Okay, so I'm just gonna ignore that mercury for now because that's just the exception. Okay, because of the metallic bond within mercury. But what you can take away from this table is that just note that the one that have for example, right, hydrogen bonding, those are going to end up with high viscosity, and the one that have a very, very large molecule, they are going to end up with a high viscosity value as well. Okay, so they are going to be more viscous. The next property of liquid that we are going to take a look at is cohesive force. Cohesive force are the interaction or the intermolecular forces between identical molecules, such as in this case, if you're looking at a drop of water, is going to be the interaction between molecule of water with its neighboring molecule. Okay, so now if you're looking at the surface of the water, though the molecule at the surface has no interaction, right? Because already at the surface. So this unbalanced attraction on the surface is causing liquid to contract to form spherical shape as you observe water droplet. Okay, so it's come from that. It's come from the unbalanced attraction at the surface. And the next property is the adhesive force. Okay, so adhesive force are the interaction between the two different molecules. For example, if you have a drop of liquid with like a surface, right? So this surface molecule right here and the liquid, the interaction between these two is what we refer as adhesive force. The shape of the liquid on the surface depends on the relative strength between the cohesive force and adhesive force. As you see in this picture right here, if a drop of water is put on top of the hydrophobic coating, it's going to form a spherical shape, versus if you put water, right, drop on a surface that is coating with hydrophilic coating, is going to spread out. The reason for that is because if you're looking at this surface right here, because the surface is hydrophobic, it doesn't like water. Therefore, in this case, water molecule will not interact well with the surface. Therefore, in this case, the cohesive force within the water molecule inside the droplet would be stronger than the adhesive force, which is the force between the water molecule and the surface. Okay, so that's why you are observing the what we call a spherical shape. On the other hand, if you have water on the hydrophilic coating, philic mean love, right? So this is going to be the substance that love water. Therefore, in this case, water would interact well with the coating. In this case, the adhesive force would be stronger than the cohesive force. Therefore, in this case, you're going to see that the water droplet would spread throughout that coating, okay, because water interact well with the coating. Okay, so the two shape of the liquid would depend on the strength between cohesive and adhesive force. The next property that we are going to take a look at is the surface tension, which is the resistance of the external force due to the cohesive force. For example, in this case, as you see, right, all of these are cohesive force, and the force that ability for the liquid to resist the external force, that is what we call surface tension. Here's the table of surface tension of common substances at 25 degrees Celsius. We are going to ignore mercury because the reason why mercury has high surface tension is because of the metallic bonds. Okay, so metallic bond is not in thermal forces, so I'm not going to talk about this. Okay, so in this case, I would like you to circle water instead. The reason why water has high surface tension is because of the hydrogen bonds that we mentioned in the previous video, right? Because hydrogen bonds can form in water. Hydrogen bond can also form in ethanol as well, and also ethylene glycol. But of those, you will see that those also have high value of surface tension as well. But hydrogen bonding can form more in water in this case, so that's why surface tension would be higher than ethanol or ethylene glycol. The next thing we're going to take a look at is capillary action. Capillary action is the ability of liquid to flow up against gravity, which is what we observe in water uptaking for plants, right? And also you are going to do this chromatography later on in this term as well. And also, you know, like with the capillary tube, when you like draw blood. So all of these are part of capillary action. Okay, so pretty much it rely on two type of forces. Okay, so one is cohesive, the other one is adhesive. So pretty much cohesive going to be the attraction between liquid, and adhesive would be the liquid and the tube surface. The relative strength between the cohesive and adhesive force will determine the shape of the meniscus of the liquid inside the tube. For example, as you see in this figure right here, one is water and the other is mercury. Water is dyed in red, so that way it's easier for you to see. So for water, you will observe that cohesive force is going to be less strong than the adhesive force, as you see, right? So because water adhere to the surface really well, right? Because of stronger adhesive force, you are going to observe the concave meniscus. Whereas if you're looking at mercury, for mercury, the cohesive force between mercury atom is stronger than the adhesive force between the mercury and the surface of the tube. Therefore, in this case, you are going to observe the convex meniscus. The diameter of the tube also has an effect on how liquid can flow up against gravity as well. So as you can see here, the tube that has a smaller diameter, the liquid would be able to flow up against gravity higher than the one that have a bigger diameter. And also the density of the liquid also play a role in how liquid can flow up against gravity as well. Those liquid that have less density is going to be able to flow up against the gravity better. Therefore, in this case, the height of the liquid is going to be inversely proportional to the density of the liquid. Here are an example of the question that you will be asked about the property of liquid, right? So it's mostly it's going to be multiple choice or short answer. So I would like you to pause the video now and then complete these problems here. And once you complete, you can resume the video again to check your answer. All right, let's check your answer together. Okay, so the first one, capillary action is going to be both cohesive force and adhesive force. Okay, so as we see earlier, if cohesive force is weaker than adhesive force, you are going to observe the concave meniscus. If the cohesive force is stronger than adhesive force, then you are going to observe convex meniscus. 2, which of the following gives rise to the surface tension? The answer for this would be just the cohesive force. Okay. 3, which of the following is a factor that affects the viscosity of the liquid? Okay, so the answer would be molecular size and shape, okay, as well as temperature, as well as intermolecular forces as well. Okay. Number 4, why does water have such a high surface tension? The reason for that is because water exhibits strong hydrogen bonding that hold them together. Number 5, why is warm honey easier to pour than cold honey? The reason for that is because as the temperature increases, right, kinetic energy of the molecule increase. Therefore, in this case, it's going to make it easier to overcome the attractive force between molecules, making honey molecule move easily. Therefore, in this case, honey would become less viscous at higher temperature because of that, because of less attractive force between molecules. Now, number 6, determine whether each of the following is an example of surface tension, capillary action, or viscosity. So fly fishing, or floating on water would be an example of surface tension. Okay. Engine oil flowing slower than gasoline, that would be viscosity, right? So it just means that molecule of engine oil probably be longer, more entangled, right, than gasoline. C, this would be a capillary action, right? So paper towel soak up water. Okay. Number 7, sketch picture of a drop of water on a hydrophilic surface and hydrophobic surface. Okay, so a drop of water. So a drop of water on a hydrophilic surface would look like this because water would interact well with the surface, right? Because the surface love water. However, if you drop water on a hydrophobic surface, then it's going to stay as a spherical shape. The reason for that is because in this case, cohesive force is stronger than the adhesive force between water molecule and the surface. Okay, because surface doesn't like water. Okay. Number 8, draw correct shape of the meniscus of a liquid in the tube below when cohesive force is greater than adhesive force. If cohesive force is greater than adhesive force, you are going to end up with the convex meniscus. All right, so that's the summary of the property of liquid. Okay, so please start working on your homework 10.2 as soon as possible.